In today's video, we'll be diving into the newly supported JSON Lines serialization data format, which is a highly efficient JSON data format that is perfect for streaming parsers and text processing. JSON Lines has become increasingly popular for maintaining large datasets, especially in the AI community. We'll be exploring how to work with JSON Lines data and demonstrate some example usages. JSON Lines, also known as JSONL, is a data format that structures data as individual new line delimited JSON objects. Unlike traditional JSON files where multiple objects are wrapped in an array, JSON Lines separates each object by a new line character, making it easily parsable by stream parsers and text processing tools. Because we're serializing the same type of object for each new line, this acts very similarly to the CSV serializer when it comes to configuring your DTOs for serialization. Your autoquery services automatically support the JSONL data format by returning the data type that's configured with the autoquery endpoint for each new line returned in the stream. For other endpoints, by annotating our response DTO with data contract or the CSV attributes specifying the first enumerable CSV behavior, the first IEnumerable property of your response DTO will automatically be serialized in the streamable JSON Lines format. Clients can request the JSONL format in the usual ways, such as using the format query string, ending the endpoint suffix in .jsonl, or specifying the accepts header with text JSONL. One of the key advantages of the JSON Lines data format is the ability to parse the data line by line, which is particularly useful for handling large datasets on clients which are memory constrained. We can see this with the use of common bash tools like curl and JQ to pull out the data we want quickly and efficiently. Here we have a Blazor gallery endpoint showing albums, and if we want to pull out just the title name of each album, we can do this by specifying the URL with curl and the option -s for silent, and piping the output to JQ with the argument .title to pull out the title property of each object. And we can do something similar from C# by using the utility method getStreamFromURLAsync. We can then read that stream line by line using stream.readLinesAsync in a for each loop. And because we know that each new line is the same type of JSON object, we can deserialize it and perform our processing before moving on to the next line, keeping our application memory footprint small and efficient. If your client isn't operating in a memory-constrained environment, or you don't require asynchronous streaming and prefer to work with the entire dataset at once, you can use the JSONL serializer directly to deserialize the JSON Lines payload. In this case, we can use the getStreamFromURLAsync utility method to load the entire JSON Lines payload and then call JSONL serializer.deserializeFromString, specifying the list of the type you need to deserialize. If you want to serialize an array into a JSON Lines payload, you can use serialize to string, serialize to stream, or serialize to writer. Diving into a practical demonstration of using JSON Lines, we will index the AI-generated art albums from the Blazor Diffusion website. We will first fetch the data from the Blazor Diffusion API, which provides creatives, which are generated based on user-provided text prompts. Our goal here is to index the text and the image URL of these creatives into a Typesense server for easy searching. The API endpoint we'll be using is the /creatives.jsonl. This endpoint will return our creative as well as the related artifacts. Artifacts are the images related to the original prompt in the creative. We can use the same C# code that we saw in our previous example to process the creative one at a time. For each new creative, we want to pull out a few details about the prompt and the image URLs, and then pass them to a running Typesense server that we have running locally. The full process is that we initialize our Typesense client, create a creatives collection, which is where our index documents will live, pull out the URL and the text prompt for each creative that we find, and create it as an index document on our Typesense server. By using our JSONL data in this way, we can log our application's memory usage each time we process an index to show that it isn't growing, but rather being constrained relative to the size of each index. If memory usage isn't a concern, we can take advantage of the asynchronous stream processing that JSONL gives us and change our for loop into a parallel for each. And with this simple change, our processing of 1,000 creatives goes from 6 seconds to around 1 second. If we want to process more than the 1,000 results that AutoQuery will return by default, we can track the ID of the last indexed creative and then use the query string for the AutoQuery endpoint ID greater than, and then passing in the last indexed creative, followed by the order by ID. This will ensure we crawl all the creatives from the Blazor Diffusion API, going from oldest to newest, and run this program in a polling fashion to check for newly generated creatives. To quickly check if our creatives have been successfully indexed, we can use the Typesense Dashbord project. This comes with a desktop application so you can look at what is indexed in your Typesense server, and here we can see all our creatives with the related prompt text and the URL. I'll leave a link in the description to this project and Typesense so you can try this out yourself. That wraps up our exploration of the JSON Lines data format and its usage with ServiceStack endpoints. I hope you found this video useful and it inspires you to check out JSON Lines for handling large datasets in your own projects. If you have any questions or feedback, please leave a comment below or join us on our Discord server, GitHub discussions, or customer forums. And as always, thanks for watching.